Alrighty, we are talking about classifying triangles today by their angles, by their sides, and yeah, that's pretty much it. Okay, so let's go ahead and look at numbers 1 through 4. Okay, so it's asking us to classify each triangle by its angles. Okay, so that means the angle measure. Now it doesn't explicitly give us angle measures, meaning how many degrees these angles are. But there's a few different triangles that they could be. Okay, so the options that we're given can be a right triangle, meaning it has a right angle. It can be an acute triangle. In fact, let's write those definitions. A right triangle is when contains a right angle, or 90 degrees. Okay, an acute triangle is when all three angles, I'm just going to write the symbol for angles, are less than 90 degrees. And then we have an obtuse angle, where one angle is greater than 90 degrees. Okay, so those are basically our three types of triangles that we can classify when looking at their angle measures. Okay, so let's look at number 1. Okay, so I'm going to go ahead and just put some angle measures on here. Let's just say this guy is 70. Let's say this guy is 60, and then the third guy, if it has to equal 180, that'd be 70 plus 60 is 130. So that guy has to be 50. Okay, so now looking at all these angles, that helps us kind of see how big these angle measures are. Which one would this angle be classified under? Would it be a right triangle, where one of the degrees is 90 degrees? Would it be an acute triangle, where all 3 degrees are less than 90? Or would it be obtuse, where one of the angles is greater than 90 degrees? Okay, well, we see 70, 60, and 50. That means all 3 angles are less than 90 degrees. So we'd classify this guy as an acute angle. Okay, think little angles, acute. Okay, kind of a fun way to remember that. All right, now let's look at number 2. So we see this straight up and down. It's what we call perpendicular. Okay, that is a 90-degree angle right there. Okay, then we'll say that this guy is 60 degrees. Why not? That guy can be 30 degrees. Okay, so knowing that it has a right angle in it, or that 90-degree angle, then what type of triangle is it? Right, acute, or obtuse? Okay, this one's pretty easy. If it has a right angle in it, we know it's a right triangle. So we classify it as right triangle. Okay, now number 3. Okay, I'm gonna go ahead and say that this angle is 60, and they all look pretty similar, 60, 60, and 60. Okay, they're all angles that are not perpendicular. They are less than 90 degrees. All 3 of them are less than 90 degrees. So again, this guy would be classified as acute. Okay, number 4. All right, we definitely see that this angle is less than 90. I'm gonna go ahead and say that's like 40. Why not? Then we'll say that this guy is 40. He looks kind of similar. Then this guy, you can see it doesn't have, it's bigger than that right angle. That right angle would come down right about there. So we're gonna say that's like 100 degrees, bigger than 90 or more than 90 degrees, okay? So if it has one angle that is greater than 90 degrees, we classify that as an obtuse angle. So that's an obtuse angle. Beautiful. All right. Numbers 5 through 8. It's now asking us to classify each triangle by its sides. Okay, so we classified them by their angles. Now we're classifying them by their sides. equal sides and equal angles, if any, are indicated in each diagram. Okay, so for numbers 5 through 8, you see these little dash marks, these little kind of curve marks right there. That tells us that either angles or sides are equal to each other. Okay, well, number 5, we don't see any dash marks indicating that sides are equal, and we don't see any of the little swooshy marks on the angles telling us that the angles are equal. Okay, so this type of triangle is what we call a scalene triangle. Okay, and let's go ahead and define that. A scalene triangle is when no sides and therefore no angles equal each other. They're all different measures. Okay, so scalene, no equal sides, no equal angles. Okay, let's look at number 6. Okay, so for number 6, I see that these two sides are equal to each other, and these two angles are also equal to each other. Okay, so actually if a side is equal to each other, then its corresponding angle, the one that's across from it, is also equal. Okay, so in a triangle, when 2 of the 3 sides are equal to each other, we call this an isosceles triangle. Okay, and we'll go ahead and define that. When 2 sides equal each other. Or in other words, are congruent to each other. Congruent, equal, same thing. Okay, awesome. So we talked about scalene, where no sides and no angles are equal. And we talked about isosceles, when 2 of the 3 sides are equal. Now let's look at number 7. Okay, so we see that 1, 2, 3. So all 3 of the sides of the triangle are equal, and therefore all 3 of the angles are also equal. Okay, well, when all 3 of the triangles are equal to each other, this is called an equilateral triangle. Kind of has that equal right there in the word, right there in the name. Okay, so an equilateral triangle is when all sides of the triangle are equal to each other. Okay, and again, that's indicated by these little dash marks. Okay, now number 8. Okay, so we've talked about when no sides are equal to each other, when 2 of the sides are equal to each other, and when all 3 of the sides are equal to each other. So looking at number 8, which one would it be? Would it be scalene, isosceles, or equilateral? Okay, well, number 8, we don't see any tick marks on our triangle that indicate the sides are equal. Also, we don't see any of the swooshies that indicate the angles are equal. Okay, so again, this guy, when no sides, no angles equal each other, is scalene. None of the sides of this triangle equal each other. Okay, awesome. So we know how to classify triangles now by its angles. Okay, acute, right, and obtuse angles. And we know how to classify triangles by their sides, scalene, isosceles, and equilateral. So now for numbers 9 through 12, we are asked to classify each triangle by both its angles and its sides. Okay, so let's go ahead and look at number 9. So it's giving us our angle measures and our side measures. Okay, so let's go ahead and look at the angle measures first, since we just talked about angles first. So ignore the side measures. Just look at these guys in here. So I have 35, 110, and 35 degrees. Okay, well, in order to classify this triangle by its angles, first we have to go back to our definitions. Okay, it doesn't contain a right angle. One of the measures is not 90 degrees. All three of the measures would have to be less than 90 to be an acute, but since we have that one angle that's greater than 90, right, 110 degrees, we would classify this guy as an obtuse triangle. Okay, so that's using its angles. Now we need to use its sides. Okay, so I have a side measure of 3.1, 3.1, and 5.1. Okay, so I see that 3.1 and 3.1 are the same measure. That's why I put that little tick mark. These guys are equal. They're not equal to 5.1. So now look back at our definitions of the sides. Which definition is it when two of the sides are equal? Okay, this guy would be an isosceles triangle. So its full classification would be an obtuse isosceles triangle. Obtuse because of our angle that's greater than 90. Isosceles because two of the sides are equal to each other. Okay, number 10. Again, let's go ahead and just start with the angles first. Okay, so I see a 90, which can also be indicated by the little box symbol. I see a 52 and a 38. Okay, well remember, right angles are 90 degrees. Whenever you see that 90 degrees, we automatically know it's a right triangle. Okay, so since it has one of those guys as 90, we would classify this as a right triangle for its angles, and now we just need to look at the sides. So I have 2.2, 2.8, and 3.6. Okay, well 2.2, 2.8, and 3.6 are all different numbers. Okay, which means none of these guys are equal to each other as in regards to their sides. So the definition where none of the sides are equal to each other would be scalene. So the full classification for number 10 would be a right scalene triangle. Okay, number 11. Let's look at the angles first. So I have 75, 75, and 30. Okay, so I don't see a right angle, meaning there's no 90 degrees. I don't see any measures that are over 90 degrees, but bigger than 90. But I notice all three of these angles are less than 90, right? 75, 75, and 30 are all less than 90. So we can classify this guy by its angles as acute. Okay, now let's go ahead and look at the sides. I have 2.1, 4.1, and 4.1. Okay, well I know that 4.1 is equal to 4.1, which means those two sides are equal to each other. Okay, and which definition is it when two of the sides are equal? Again, this would be an isosceles. So full classification, an acute isosceles triangle. And number 12. Okay, let's look at our angles. I have 30 degrees, 130 degrees, and 20. Okay, I see no right angles, no 90 degrees, but I do see one of the angles that is bigger, larger than 90 degrees, which is 130. So whenever I see an angle that's larger than 90 degrees, I can automatically assume this guy is an obtuse triangle. Okay, now I just go ahead and look at the sides. 2.1, 3, and 4.6. Okay, are any of those sides equal to each other, meaning they have the same measure? Nope, 2.1, 3, and 4.6 are all different measures. So the definition when they are all different would be scalene. So this guy is an obtuse scalene triangle. And that is how we classify triangles with both their angles and their side measures. Those are your notes for today. There's an assignment that goes with it.